Hello friends, this video on equilibrium part 42 is brought to you by examfear.com. No more fear from exam. Before watching the video, please make sure that you have watched all the previous parts. Now we'll learn a very interesting topic called buffer solution. Buffer solution, the name sounds very fancy. What is buffer solutions? Buffer solution is nothing but a solution which resists change in pH. Even if you add some amount of acid or base to it. So in the solution, even if you add some H plus ion, it won't change the pH. Or small OH minus ion, it won't change the pH. Sounds very good, right? So there's a solution which doesn't change the pH even if you add some small amount of H plus or OH minus ions. So what is the use of buffer solution? It plays a very critical role in our biochemical and chemical process. We will talk about that. If you see the blood is an example of buffer solution. It has a specific pH. Even you try to increase or decrease the H plus ions concentrations, the pH won't change. We'll discuss about the buffer solutions. There are four kinds of buffer solution: strong acid buffer, strong base buffer, weak acid buffer, and weak base buffer. We'll discuss all these four now. Strong acid buffer. If you take very strong acid like HNO3, HCl, they are also a buffer with a low pH. Why? Because even if you add something, some OH minus ion, that will be used, right? The change in pH will be very less because it's very acidic. Right? Since it is very strong acid, even if you add small drops of OH minus ion, this will be used somewhere. It won't lost. It will lost in translation. It will be lost. It will be always acid. Same thing with the strong base buffer. If you have very strong base, NaOH or CoH, even if you add small amount of H plus ions, it won't make any difference in the pH. It's a strong base buffer, but strong acid and strong base is something which we don't want, right? In real life, you want something weak acid or weak base. But in weak acid and weak base, if you normally add any H plus or OH minus ions, it will change the pH. So what should we do? So for weak acid buffers, we have to do something different. So what we do here is we take weak acid and their salt in strong base. I'll tell you how. Example, my acetic acid is a weak acid, right? And I take sodium acetate, it's a strong base. It has a pH of 4.75. It's constant. And how it is constant, I'll tell you. For example, in this case, my acetic acid hardly dissociates. So most of the amount will be acetic acid and a very few amount of H plus and CH3O, CO minus ions will be there. Similarly, CH3CO Na will dissociate completely almost. So large amount of CH3CO minus and Na plus will be there. Now, if I try to add, let's suppose OH minus here, what will happen the moment I add OH minus ion? What will happen is it will combine with H plus ions. Can it combine with Na plus? No, because if you see NaOH is a strong base, it wants to be in Na plus and OH minus 90% of the cases here. But H2O is a very weak thing. So H plus and OH minus hardly 1%. It always tries to be in this part, 99%, right? So it always tries to be in this part. In this case, always tries to be in this part. So if you add H plus OH minus ions, H plus will take that and form this. And if you add, let's suppose H plus here, then the CH3CO minus will take this H and form CH3COH. If CH3COH is formed in more quantity now, this reaction will kick off and create. So it's quite a balance, right? If you add H plus, CH3CO minus is absorbing it. If you add OH minus, H plus is absorbing it. So we have readily free ions to absorb extra H plus or OH minus ions. That's why it's a buffer, right? So in this case, if you see, if you add OH minus ions, Na won't take, H plus will take and form water. If you add H plus, CH3CO minus will take it to form CH3CO. So even if you add more H plus here, because a large amount, it can withstand a lot of H plus ions. Because it's a weak acid buffer. Correct. Similarly, we have weak base buffer. So we have weak base plus salt of strong acid mixture. For example, in this case, we have ammonium chloride and ammonium hydroxide. My weak base was ammonium hydroxide, and then I got ammonium True, right? Now in this case, if I want to add H plus, what will happen? It will combine with this guy. If I want to add OH minus, it will combine with this guy. H plus won't combine with Cl minus here, right? So in this case, this can withstand a lot of OH minus here because we can withstand a lot of this guy because we have more here in H4 plus. So it can withstand a lot of OH minus. If you add a lot of base also in this, it can withstand the pH value. More and more OH minus you add, it will just consume it and it won't let the pH to go up. And its pH is around 9.25. Let's take some questions here. So we have to find the pH of the resultant mixtures: 10 ml of 0.2 m CaOH2 and 25 ml of 0.1 m HCl. So we have this reaction CaOH2 plus 2HCl equilibrium with the CaCl2 plus 2H2. This is the reaction here, right? So at T is equal to 0, what is the concentration of this guy? CaOH2 and HCl. That is something we have to find. So there is an acid here and there is a base here, right? So first there is a base, this is acid. It will react from salt and it will become either acidic or basic. So let's find the number of moles. So we have 10 ml of 0.2 m CaOH2 is nothing but 10 into 0.2, that is 2 millimoles of CaH2. Similarly, we have 25 ml of 0.1, that is 2.5 millimoles of HCl. Correct? So let's have this reaction first. CaOH2 plus 2HCl, CaCl2 plus H2. So let's assume T is equal to 0. I had 2 moles of this, 2.5 moles of this, 0 moles of this, 0 moles of this. This, let's suppose, takes X, right? So it will take 2.5 minus X, 2X actually, correct? Because this is 1, this is 2, stoichiometric coefficient, and this will form X, this will form 2X. Now if you see, this is 2, since it want to react, what if X is equal to 1.25? Then whole of the HCl is gone, right? X can have 1.25 value also because it's neutralization reaction. So let's assume X is equal to 1.25. So this becomes 2.5 minus 2.5, that is 0. This becomes 1.25, this becomes 2.5, and this becomes 2 minus 1.25. Right? T is equal to equilibrium, you can see. So if you see, this is 0 now, this has this value, and this you can ignore also, and let's ignore that part. So we have this as 0.75 millimoles. So, but we have to find the molarity now, right? So molarity is what? Moles by volume. What is the total volume? 10 plus 25, 35. So molarity of CaOH2 is what? We have 0.75 by 35 milliliter. So this becomes in M. This is 0.0214 M. This is what we get. This was in millimoles, this is milliliter, so cancels and you get this much molarity of the CaH2. So now this means that after this reaction, HCl is gone, I am left only with CaOH2. So I can have this reaction now. CaOH2 will react to form Ca plus 2OH minus ions. So I have to find the pH. That means if I have 0.0214 and 0 here, T is equal to 0, so T is equal to equilibrium, this will become 0, this will become 2 into 0.0214 M. Correct? So OH minus concentration is what? 0.0428 M. So I can find POH. pOH is what? Minus log of this value, 0.0428. This is nothing but 1.37. My pOH is 1.37. pH is what? 14 minus 1.37. That is 12.6. And that is my answer. See, in this case, what happened was COH2 and HCl were reacted. The HCl was totally consumed. We have only CaH2. But the number of moles of CaH2 was lesser now. The sum of the CH2 was used to react with HCl. Now, with whatever number of moles we have for CH2, we found the number of OH minus ions will get, so that we can find the pH. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.